This is SpaceTime, Series 26, Episode 120, for broadcast on the 6th of October 2023. Coming up on SpaceTime, new simulation shedding fresh light on the origin of Saturn's majestic rings, why our Milky Way galaxy's warped, and a record-setting space station crew returns safely to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new series of supercomputer simulations have offered an answer to the mystery of the origins of Saturn's spectacular ring system. This one involves a massive collision in the recent history of the 4.6 billion-year-old solar system. Now, according to this new research, which is reported in the Astrophysical Journal, Saturn's rings could have evolved from the debris of two progenitor icy moons that collided and shattered just a few 100 million years ago. The two moons would have been similar in size to two of Saturn's current moons, Dione and Rhea. And the debris that didn't end up in the rings could have contributed to the formation of some of Saturn's present-day moons. Most of our contemporary high-quality measurements of Saturn have come from NASA's Cassini spacecraft. Cassini spent 13 years studying the ring world and its system of moons after achieving Saturnian orbit insertion in 2004. During that time, the spacecraft captured precise data, passing by and even diving into the gap between the Saturnian rings and the planet itself. Cassini found that Saturn's rings are almost pure ice, and they've accumulated very little dust pollution since their formation. And all that suggests that they must have formed very recently in the history of the solar system. Motivated by the remarkable youth of the rings, the authors turned to the Cosmo machine, which is hosted by Durham University as part of the UK's DIRAC Distributed Research Utilisation Advanced Computing Facility. They modelled what different collisions between precursor moons would have looked like. These hydrodynamical simulations were conducted using the Swift open-source software at resolutions more than 100 times higher than previous studies, giving scientists their best insights yet into the Saturnian system's history. One of the study's authors, Vincent Eck from Durham University, says an impact of icy moons is able to send enough material near to Saturn to form the rings that we can see today. The scenario naturally leads to ice-rich rings because when the progenitor moons crash into each other, the rock in the cores of these colliding bodies is dispersed less widely than the overlying ice. Saturn's rings live close to the planet within what's known as the Roche limit. That's the distance from a planet at which point its gravitational tidal forces will stress and tear apart a smaller celestial object, which is held together purely by gravity. Inside this Roche limit, any parts of a moon closer to Saturn are attracted more by the strong pull of the planet's gravity than other parts of the moon further away, and that causes the moon to physically pull itself apart, forming the rings. And any material outside this Roche limit would coalesce to form new moons. By simulating some 200 different versions of the impact, the authors discovered a wide range of collision scenarios that could scatter the right amount of ice into Saturn's Roche limit. There, the ice would settle into rings, just as we see them around Saturn today. But since other elements in the system have a mixed ice-rock composition, alternative explanations haven't been able to explain why there would be almost no rock in Saturn's rings. This is SpaceTime. Still to come, why is our galaxy so warped? And a record-breaking space station crew returns safely to Earth. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, NordVPN. As we explore the vast mysteries of the universe together, there's another vast space that I want to talk about, and that is the digital realm of the internet. Just as there are unknown threats throughout the cosmos, there are data thieves online, lurking and waiting to snatch your identity and personal details. And that's why we trust NordVPN to keep us secure. With NordVPN, we're not just browsing, we're browsing with a shield. Its top-tier encryption ensures that our personal details stay exactly that, personal. But it's not just all about security. With NordVPN, we experience blazing fast connections. And with servers in over 60 countries, it's like having a passport to the digital world, accessing content from all corners of the globe. Now, if you're still hesitant, here's something that should ease your mind. NordVPN offers a 30-day money-back guarantee. So you really can give it a test drive without any worries. And as a dedicated SpaceTime listener, we of course have a special deal for you. By using our exclusive offer, you get up to 4 months extra for free. All you need to do is visit nordvpn.com/StuartGary or use the checkout code StuartGary. That's nordvpn.com/StuartGary or the checkout code StuartGary and get up to 4 months extra coverage for free. And of course, we have all the URL details in our show notes and on our website. So, as we're journeying through the wonders of the universe, let's ensure that our journey stays safe online with NordVPN. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
Now, while we're on the subject of computer modelling, new computer simulations may have helped astronomers resolve some of the mysteries surrounding the recent discovery that the Milky Way galaxies actually warped. Most spiral galaxies like the Milky Way have sweeping spiral arms that stretch out from the galactic bulge and, when viewed edge-on, appear almost flat. But recent observations by the European Space Agency's Gaia Space Telescope showed that the spiral arms of the Milky Way are slightly warped near the end tips of the spiral arms, with one side flaring upwards and the opposite side flaring down. Now, most hypotheses to try and explain this odd warping of the Milky Way have revolved around the idea of a collision between the Milky Way and another galaxy, most likely the Sagittarius Dwarf, a small satellite galaxy which has already passed through the Milky Way's disk on several occasions, losing more stars than gas with each encounter. Eventually, Sagittarius Dwarf will be completely consumed by the Milky Way, becoming another example of galactic cannibalism. But the idea of galactic collisions can't fully explain the observations. Now, a report in the journal Nature Astronomy claims computer simulations based on new modelling could be explained by a tilt of the dark halo. The authors found that the Milky Way's galactic halo is slightly off-kilter compared to the disk that makes up the bulk of the galaxy itself. Now, they believe the only thing that could have caused the galactic halo to tilt in such a way would be an imbalance in the dark matter permeating the galaxy. The authors then developed a computer simulation of the once infant still forming Milky Way galaxy and, after a lot of trial and error, found a 25-degree tilt in the galaxy's dark matter halo slowly led to the spiral arms developing their current warp over a period of about 5 billion years. They suggested the dark matter halo itself was slightly tilted by the gravitational interaction caused by a collision with another galaxy. And once again, thanks to Gaia, we know the Sagittarius Dwarf galaxy probably collided with the Milky Way spiral arms about 5.7 billion years ago. There was a second collision about 1.9 billion years ago, and a third one about 1 billion years ago. This is SpaceTime. Still to come, a space station crew returned to Earth after a record stay in orbit, and we check out our nearest neighbouring star system, Alpha Centauri, 2 of our nearest neighbouring galaxies, the Large and Small Magellanic Clouds, and 3 meteor showers, all of which are among the highlights of the October night skies on Skywatch. Two Russian cosmonauts and an American astronaut have landed safely back on Earth after spending over a year aboard the International Space Station. Their Soyuz 23 spacecraft floated down onto the Kazakhstan steppe in overcast skies near the city of Zhezkazgan under a giant orange and white parachute.
Now, right after the completion of the deorbit burn, the orbital module, the top section of the Soyuz spacecraft, the three-section Soyuz spacecraft, it was depressurized about 10 seconds after the conclusion of the deorbit burn, setting the stage for the module separation that's coming up. The precise landing coordinates being relayed to the crew on board the Soyuz. The current projection by the ballistics officers for the RSC Energia team at the Russian Mission Control Center shows the landing site at 47.20 degrees north, 69.39 degrees east. That is where the search and recovery forces will be positioned to greet the Soyuz crew following touchdown. And now reports having been received from the Russian Mission Control Center of a nominal separation of the three sections of the Soyuz. Module separation is now complete. That all went by the book. The next milestone about 3 minutes from now, and that will be the Soyuz hitting the top of the Earth's atmosphere.
Hudson Station on 2 for OCT2.
The Russian Mi-8 helicopters, part of the Rosaviatsa search and recovery forces, are nearing the landing site southeast of Zhezkazgan to move into a racetrack pattern, an oval-shaped pattern around the landing zone, awaiting the arrival of the Soyuz spacecraft with touchdown scheduled about 23.5 minutes from now. Flight controllers in Korolyov outside Moscow receiving data from the Soyuz spacecraft through their communications satellites, the Luch system. The Soyuz now has entered the Earth's atmosphere. The three crew members feeling the first effects of gravity on their bodies in 371 days. Just over 8 minutes until the scheduled deployment of the parachutes. The Soyuz currently descending through the Earth's atmosphere. As expected, we are not receiving voice communication from the crew. This is typical at this point of the entry sequence. Once the spacecraft passes through the plasma regime, the period of peak heating, we should be hearing from the crew once again with communications relayed through the Antonov 26 fixed-wing aircraft in the vicinity of the landing site. The Soyuz should be emerging from that plasma regime any minute. This is the point where the crew is experiencing maximum G loads on their bodies of about 4 to 5 Gs. And there is that familiar beacon signal coming from the Soyuz MS-23.
A report on maximum G. We have 4.4 maximum G load. Copy.
Интеграл плюс 18.
Integral
Индекс кривой.
plus 1.8. The index is along the curve.
Sergei Prokopiev, the Soyuz commander, reporting that everything is in great shape on board the Soyuz. The crew experiencing those maximum G loads, but they are through the plasma regime as we stand by just over a minute from now for shoot deploy.
Notable and G load is decreasing.
Good communication now being received from the Soyuz MS-23.
And how are you feeling? We are feeling great. Thank you. And of control.
Sergei Prokopiev reporting that the crew is feeling well. Great news as the Soyuz MS-23 approaches its landing site in Kazakhstan. We should be getting confirmation momentarily on the opening of the chutes. The Russian Mi-8 helicopters, part of the search and recovery forces, are approaching on station in the landing zone around where the Soyuz will touch down. We now have confirmation that the Soyuz parachute has been deployed. Once again, the Soyuz MS-23 is now descending toward its landing. Just about 11 minutes from now, its parachute has deployed. The crew is feeling well, according to Sergei Prokopiev, the Soyuz commander. All of the entry events have gone by the book to this point. The skies are quite overcast at the landing site. Temperatures around 69 degrees. The search and recovery forces at the landing site now confirm that they have the Soyuz in sight under its parachute. All of the events to this point have been a winner. Everything has gone according to schedule, and the crew, according to Sergei Prokopyev, the Soyuz commander, is feeling well. The Soyuz MS-23, it is gently descending under its large orange and white parachute. Search and recovery forces are reporting back that everything is looking good from their perspective. There were some rain showers in the area earlier today. The Soyuz descending under several decks of broken clouds toward its touchdown point about 90 miles to the southeast of Zhezkazgan. The extended mission of Frank Rubio, Sergei Prokopyev, and Dmitry Petelin is now in the home stretch after more than a year in space, less than 4 minutes from touchdown on the desolate steppe of Kazakhstan. The parachutes deployed as planned at 6:03 a.m. Central Time. 3 minutes later, the Soyuz heat shield was jettisoned.
409. Confirm.
The next event will be just a second or two before touchdown. That'll be the firing of the soft landing engine. 6 engines fire to slow the Soyuz descent rate to just 1.5 meters per second.
Prepare. 100 meters to ground.
100 meters to go. The crew being told to brace for touchdown.
Object getting close to touchdown. Object.
Touchdown. Touchdown confirmed at 6:17 a.m. Central Time. Rubio's record ride comes to an end as he, Prokopyev, and Petelin return to Earth after a 371-day, 157 million-mile journey at the International Space Station. The third longest flight ever in human spaceflight history is over with a pinpoint landing on the steppe of Kazakhstan.
The three had travelled to the International Space Station last year on a mission that was meant to last 6 months. But their original MS-22 capsule developed a coolant leak while docked to the orbiting outpost. Engineers with the Russian Federal Space Agency Roscosmos determined a micrometeoroid impact likely caused the leak. But just 2 months later, the exact same coolant leak developed on a Russian Progress MS-21 cargo ship, which was also docked to the space station. And the idea of 2 micrometeoroids hitting 2 separate spacecraft in exactly the same position isn't very likely, but it does follow a pattern. These incidents follow the formation of several air leaks, both in Russian spacecraft and in modules aboard the Russian segment of the space station. And there have been other problems with Russian equipment as well. There was that abort during ascent of the Soyuz MS-10 mission to the space station just 2 minutes into the flight back in 2018. That was caused by a strap-on booster crashing into the core stage of the Soyuz rocket. And then there was the sudden unprogrammed ignition of a thruster aboard the new Russian Nauka science module on the space station, sending the orbiting outpost tumbling out of control for 45 minutes. Neither mission managers nor the crew on the space station could turn the thruster off, eventually having to resort to turning on another thruster to try and balance the load. The thruster on the Nauka eventually turned off only when it ran out of fuel. As for the Soyuz MS-22 incident, without coolant, mission managers were concerned that temperatures inside the capsule could reach over 40 degrees during re-entry, making the trip uncomfortable for the crew. And of course, who knows what else was going wrong? So the Soyuz MS-22 was returned to Earth empty, and a replacement, the Soyuz MS-23, was instead sent up empty in late February, its original crew being bumped to the Soyuz MS-24 flight, which only arrived at the space station last week. This gave the Soyuz MS-22, now MS-23 crew an extra 6 months on station. The MS-23 landing established American astronaut Frank Rubio as the new holder of the single longest mission flown by an American astronaut, 371 days. But of course, Russian Valery Polyakov retains the all-time record for the longest single spaceflight after spending 437 days aboard the space station. The International Space Station remains a rare venue of cooperation between the West and Russia as tensions intensify over Moscow's invasion of Ukraine. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for October on Skywatch. October is the 10th month of the year, and that may seem confusing since octo in Latin means 8 rather than 10. The answer lies in the old Roman calendar, which had just 10 months before the addition of January and February. and that 10-month year is still reflected today, with the names September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. Of course, the highlight of October for kids and those who are young at heart has to be the last day of the month, celebrated as All Hallows Evening or Halloween. Halloween is based on ancient Celtic pagan festivals such as Samhain, the Gaelic festival of the dead. Samhain was eventually Christianized by the early church to become All Saints or All Hallows Eve, or simply Halloween. It's a time when darkness overtakes the light of day, a reference to the increasing hours of darkness as the planet's northern hemisphere moves towards longer winter nights. And so it's a time when the harvest comes to an end. The increased hours of darkness mean the boundary between the world of the living and the world of the dead becomes especially thin, allowing the dead and supernatural to rise in search of the living. And so the living wear disguises so as not to be recognized by the dead. And it's this which has led to today's tradition of the Halloween fancy dress party. In some parts of the world, cross-dressing is popular on Halloween, a reflection of the secret desires and fantasies of their pagan ancestors, sometimes not so many generations removed. To ensure that crops and livestock survive the cold winter months ahead, offerings of food and drink will be left outside for the spirits and fairies of the other side. And it was this which ultimately led to today's practice of trick-or-treat. Also, candles would be lit and prayers offered to the souls of the dead, as Halloween was a time when the spirits of the dead would return to their former homes. Special bonfires were also lit on Halloween to light the darkness, thereby preventing souls of the dead from returning and keeping the evil away. The flames, smoke and ashes were deemed to have protective and cleansing powers and were used for divination. As for the tradition of carving pumpkins into jack-o'-lanterns, well, that was originally meant either to represent spirits or supernatural beings, or alternatively to ward off evil spirits. In many parts of the world, the Christian religious observances of All Hallows Eve include attending church services and lighting candles on the graves of the dead. And Christians historically abstained from eating meat on All Hallows Eve, a tradition reflected in the eating of certain vegetable foods on the day, including apples, potato pancakes, and soul cakes. Apple bobbing originated because the apple was a Celtic symbol of love, and so grabbing the apple with your teeth had certain erotic overtones. Halloween is a time of fortune-telling and divination games, playing pranks to scare people, visiting haunted attractions, telling scary stories, and of course watching horror movies. Looking to the southwest, you'll see the two bright pointed stars, which show the way to the Southern Cross. The brightest, and what also looks like the more distant of the two stars from the Southern Cross, is Alpha Centauri, which is actually the nearest star system to our own solar system. Alpha Centauri is a triple star system comprising two stars, Alpha Centauri A and B, which orbit each other in a binary, and a third star, Proxima Centauri, which orbit the pair. Like the Sun, Alpha Centauri A is a spectra type G yellow dwarf star. It's about 10% more massive than our Sun and about 1.5 times as luminous. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are the spectral type M red stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now you put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can be up to 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarf stars we mentioned earlier. These can be 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Alpha Centauri A's binary partner, Alpha Centauri B, is a spectrotype K orange dwarf star, a little smaller and cooler than its companion, with about 90% of the Sun's mass and about half its luminosity. This binary pair, Alpha Centauri A and B, orbit each other at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres, or around 8.3 light minutes. So the pair's orbit around each other varies by between the average distance between the Sun and Saturn and between the Sun and Pluto. It takes the two stars 79.91 Earth years to complete each orbit. On average, Alpha Centauri A and B are located 4.37 light years from the Sun. Now, although a light year sounds like a measure of time, it's actually a measure of distance. A light year is a distance of about 10 trillion kilometres. That's the distance a photon can travel in a year at the speed of light, which is around 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The third star in the Alpha Centauri system is a spectrotype M red dwarf star named Proxima Centauri. Right now, Proxima Centauri is just 4.25 light years away, making it the nearest star to the Earth other than the Sun. It is only loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units, or around 0.21 light years. That's about 430 times the size of Neptune's 30 astronomical unit orbit around the Sun. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting within the habitable zone of Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The habitable zone, which is sometimes also referred to as the Goldilocks zone, is that area out from a star where it's not too hot, not too cold, but just right for liquid water, essential for life as we know it, to exist on a planet's surface. The planet, known as Proxima b, takes just 11 Earth days to complete one orbit around its host star. That's far closer than Mercury's 88 Earth day orbit around the Sun. A few years ago, a second, more distant planet, Proxima c, was also discovered orbiting around the star, but well outside its habitable zone. The second and slightly fainter of the two pointer stars is Beta Centauri, and while Alpha Centauri is the third brightest star in the night sky, outshone only by Sirius and Canopus, Beta Centauri is only about the 10th brightest. Looking to the southeast, and you'll see the bright blue-white star Alpha Eridani or Achernar, which represents the southern tip of Eridanus, one of the largest and longest constellations in the sky. Achernar is located about 139 light-years away. It's actually a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. Alpha Eridani A is a hot young spectrotype B blue star. It has about 6.7 times the mass of the Sun and a stunning 3,150 times the Sun's luminosity. By comparison, the companion star Alpha Eridani B appears to be a spectrotype A white star with about twice the Sun's mass. The two stars orbit each other every 14 to 15 Earth years at an average distance of about 12.3 astronomical units. Because of its high rotation rate of over 16 kilometres per second, Alpha Eridani A is actually one of the least spherical stars in the Milky Way, spinning so rapidly it's assumed the shape of an oblate spheroid, with an equatorial diameter 56% greater than its polar diameter. This distorted shape means the star displays a significant latitudinal temperature, with its polar temperature being about 20,000 Kelvin, while its equatorial temperature is only around 10,000 Kelvin. That's because it's much further away from its stellar core. The high polar temperatures are generating a fast polar wind. That's ejecting matter from the star and creating a spectacular polar envelope of hot gas and plasma. Now, if you look up between the South Celestial Pole and Achernar from a really dark place, you'll see two faint fuzzy-looking clouds. Now, these aren't actually clouds. They're two satellite dwarf galaxies which orbit the Milky Way, known as the Large and Small Magellanic Clouds. They're named after Ferdinand Magellan, who became the first European to officially record them during his expedition to circumnavigate the Earth between 1519 and 1522. The bigger and nearer of the pair is the Large Magellanic Cloud, which is located around 160 light-years away. It's easy to spot about halfway between Achernar and the horizon. It's about 14 million light-years across, twice that of the Small Magellanic Cloud, which is located a more distant 200,000 light-years from the Milky Way. Now, by comparison to these two satellite galaxies, the Milky Way is huge, 100,000 light-years across. These two dwarf galaxies are separated from each other by roughly 75,000 light-years. The Magellanic Clouds were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius Dwarf Elliptical Galaxy and the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds is uncertain. Only a fraction of their gas seems to have coalesced into stars. They also probably both have very large dark matter halos. Still, one recent estimate places the total mass of the Large Magellanic Cloud at about 1/10 that of the Milky Way. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions as they're gradually torn apart and absorbed by the Milky Way. These huge tidal forces have turned both Magellanic Clouds into irregular disrupted barred spiral galaxies. The Large Magellanic Cloud still retains a very clear spiral structure, at least in radio telescope images of neutral hydrogen. But gravity isn't a one-way street, and the combined gravitational force of both Magellanic Clouds is also affecting the Milky Way, distorting the outer parts of our galactic disk. And there are streams of neutral hydrogen gas clouds and isolated stars connecting both dwarf galaxies to each other and to the Milky Way, a brilliant example of galactic cannibalism at work. Now, if you look just above the Small Magellanic Cloud using a backyard telescope or a good pair of binoculars, you'll see a small blurry dot. That is the 47 Tucanae globular cluster. A tightly packed ball of stars some 16,000 light-years away, they were all originally formed at the same time through the gravitational collapse of the same molecular gas and dust cloud. If you look to the west, you'll see the bright reddish-orange supergiant star Antares, the heart of the constellation Scorpius the Scorpion. And above it you'll see a bunch of stars stretching out shaped like a reverse question mark. That's the tail of the Scorpion. Now, just above and to the north is the constellation Sagittarius the Archer. Sagittarius shows the way to the supermassive black hole at the centre of the Milky Way galaxy, some 27,000 light-years away. This monster black hole, known as Sagittarius A star, has about 4.3 million times the mass of our Sun. Now, looking to the north-northwest this time of the year, you'll see the constellation Lyra the Harp, and its brightest star Vega, the fifth brightest star in the night sky, and one of the closest at just 25 light-years away. Vega is a spectral type A white star, more than twice the size and some 40 times the mass of our Sun. Now, just to the right of Lyra, and almost directly north just above the horizon, is the constellation of Cygnus the Swan, and its brightest star Deneb, one of the most luminous stars in the sky. Deneb is a massive spectral type A white supergiant, some 19 times the mass and over 100 times the diameter of the Sun. The star is somewhere between 55,000 and 196,000 times as luminous as the Sun. The huge range in luminosity estimate is caused by the difficulty in determining Deneb's exact distance from us. Science's best estimates place it somewhere around 2,600 light-years away, give or take 212 light-years. High in the northern sky right now is the constellation Aquila the Eagle, and its brightest star Altair. Altair is another spectral type A white star, but located a lot closer, just 17 light-years away. It's about 10 times brighter than the Sun, with about 1.89 times the Sun's mass. Despite its size, Altair spins on its axis in just 10 hours, compared to our Sun's 28 Earth day rotation. Now, these three stars, Altair, Deneb and Vega, form a stellar grouping known as the Summer Triangle. Now, also in October, there are three meteor showers: the Draconids, the Taurids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out from the constellation Draco the Dragon, and so are best viewed from the northern hemisphere. They're actually produced as the Earth's orbit takes it through the debris trail left behind by the comet 21P Shihokubini-Zina, which takes about 6.6 Earth years to make a single revolution of the Sun. The Taurids meteor shower takes place on October 10th, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Their meteors are composed of larger-than-average pebbles and dust grains, and are thought to be generated by debris left behind by the comet 2P Encke. Although it's thought that both the Taurids and Encke could be the remains of an earlier comet which disintegrated over the past 20,000 to 30,000 years, breaking into several pieces and releasing material both by normal cometary activity and possibly also by gravitational tidal interactions with the Earth and other planets. The Taurids debris stream is the largest in the inner solar system, taking the Earth several weeks to pass through and resulting in an extended period of meteor activity compared to other meteor showers, which are usually over in just a matter of days. Now, due to the gravitational perturbations of the planets, especially Jupiter, the Taurids have been spread out over time, allowing separate segments, labelled the Northern Taurids and Southern Taurids, to be observable at different times in different hemispheres. The Southern Taurids are active from around September the 10th to November 20th, while the Northern Taurids are active from October the 20th to December the 10th. The third meteor shower this month is the Orionids, which peak on October the 20th. They're caused by debris from the comet Halley, which also causes the Eta Aquarids meteor shower in May. Comet Halley takes 76 years to complete each orbit around the Sun. It'll next become visible near Earth in 2061. The Orionids are equally spectacular in both northern and southern hemisphere skies, with up to 20 meteors an hour radiating out from the constellation Orion. The best time to see the Orionids is just after midnight and right before dusk. And now, with more on the October night skies, I'm joined by leading Australian science writer Jonathan Nally.
G'day, Stuart. Yeah, well, during October evenings, we're really starting to see the summer constellations making their first appearance. And I say summer constellations, that's for us down here in the southern hemisphere. For our friends in the northern half of the planet, of course, they're the winter constellations, or we call them summer constellations. We've got the Milky Way. It's stretching from the north to the south, all the way from the north to south in the western half of the sky. This is during that evening time. You've got the constellations of Sagittarius and really impressive Scorpius, which really does look like a scorpion. They're easily visible high overhead. But as the Earth is turning, by midnight, the Milky Way will have set in the west below the horizon. Then the sort of sky is relatively empty, it seems. So you don't have any of the Milky Way up there. And we're looking out of the plane of our galaxy. Our galaxy is like a discus, like a sports discus, right? And we're out sort of about 2/3 of the way out from the middle. So if we look through the thickness of the discus, then we're looking through them into the Milky Way. But if we're looking straight up above or down below, we're looking out of the plane of the Milky Way, and that's where there are fewer stars, of course, so it does look a bit empty. So that's what it's like during the latter part of the evening during October. But, you know, still, for those of us in the Southern Hemisphere, we're reaching the time of year when the Magellanic Cloud galaxies are seen at their best. These are two nearby, fairly sizable galaxies outside our Milky Way. They're named after the explorer Magellan, and they're called the Magellanic Clouds because when you look up in the sky, if you didn't know that they were galaxies, you would think they were just little fluffy clouds, fairly dim, and you do need to get away from streetlights and things and let your eyes dark adapt to see them. But if you're out in the countryside or something, or just away from a lot of lights, then you will be able to see them, and you look up and you think, oh, what's that cloudy stuff? Actually, an entire galaxy, two galaxies, the large and the small Magellanic Clouds. So they're really, really good things to find. We've got the famous Southern Cross constellation everyone wants to see, but at the moment it's upside down, and it's either right on the southern horizon or even below it from most populated southern latitudes, depending on how far south you are. If you're in Melbourne or Hobart, you will be able to see it quite easily, but it will be down towards the southern horizon. Now, after midnight, the sky changes, so the Earth has turned quite a bit, and what we get is the Milky Way comes up again, but Milky Way in the other direction. So it's rising in the east after midnight and bringing with it all these fabulous constellations. You've got Orion and Taurus and Gemini, Puppis, Carina, Canis Major, and lots of other ones. All of them are just bursting with interesting stars and deep sky objects. So, for instance, Canis Major has the brightest star in the sky, Sirius. Taurus has the Pleiades star cluster, which I think is easily the easiest to see and probably the prettiest star cluster in the night sky. Just a pair of binoculars gives you a fantastic view. And of course, Orion has the famous Orion Nebula, which you can actually see as just a faint smudge of light with the naked eye. And if you get a telescope onto it, it looks a lot better in addition to that. Now, all those post-midnight constellations will rise increasingly earlier as the weeks go by between now and the new year, so that by the end of the year, you won't have to be staying up past midnight or getting up early in the morning. They'll be rising before midnight. So Orion and all those other ones will be in the evening sky. So we've got that to look forward to as we get towards the end of the year. Now, let's look at the planets for October. Mercury is a no-go, I'm afraid. It's around on the other side of the sun for most of this month and therefore is lost in the solar glare. The next planet out, Venus, is up and about, but you've got to be up early to see it because it's rising above the eastern horizon about 2 hours before sunrise. So if you're getting home from night shift or you're getting up early to go to work or whatever, you should be able to see Venus out there in the east, and you really can't miss it because it's really big and bright. It looks like a huge, big, bright white star. Mars, it's a bit like Mercury. It's disappeared from view this month and it's lost in the sunset glow because it's going around the other side of the sun, and it won't be back until January when we will see it again, but this time not in the west where the sun is setting, but in the east before the sun rises. So it'll be coming up over the eastern horizon before dawn. And the other planet that's easy to see in the evening sky at the moment is Jupiter. Now, it's getting brighter as it heads towards what astronomers call opposition in November, which will be when we get our best views of the planet. So go out and have a look in the east after sunset, and you'll see this fairly big, bright star-looking thing. Well, that's the planet Jupiter. It's brighter than anything else that's around there at the moment, so you shouldn't have any trouble finding it. And finally, Saturn, too, is easy to see this month. Look for it pretty much due north after sunset. So once the sun's gone down, look to the north or to the south if you're in the northern hemisphere, and it's pretty easy to see it. It's bright, it's got a slightly yellowish tint, but if you're having trouble identifying Saturn, go out and take a look on October the 24th. And the reason I mention that date is because on that date, the moon will be very close by. So all you've got to do is go out and find the moon, and then the brightest thing that's near to the moon will be Saturn. Saturn will be about 4 moon widths away from the moon. So that's one easy way actually of finding planets. Very often the moon is close to them, and so if you know when that's coming up, you can go out and say, Mars is meant to be near the moon this week, so there's the moon. That red thing there must be Mars. So you can do that with Saturn this month, October the 24th. Go out and have a look, and Saturn will be just 4 moon widths away from that. And that, Stuart, is the sky for October.
That's leading Australian science writer Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.